Hi everyone, I'm Professor Marcelo Escobar Oliveira from Federal Institute of Goiás, campus in Goiás. I'm part of a research group of energy system called NUPSE, and we are from Brazil. Well, first of all, it's a pleasure to be participating in another conference, and well, I'm here to present this work called loss analysis due to influence of harmonics in a distribution system. This work was developed by for a student of electrical engineering from our campus. Well, the work presents an analysis of electrical losses in distribution systems, considering nonlinear loads and consequently harmonics. Consider three cases: cold, mild, and hot days. Okay. For the analysis, a modified IEEE system was used because to use a Brazilian system was very difficult to find a good system to analyze this, and use this system, and we adapted it using some parents from Brazil. Okay. Well, and this system is available in OpenDSS. Okay, so the system was adjusted so that some parameters, such as voltage levels, like I said, were closer to the Brazilian electrical system. The system, the load curves are obtained using fuzzy logic for different climate cases based on occupation. Yes. So rules were defined through the days in such a way depending on the occupation, residential or commercial load, okay, consumers. From these rules, the curves were obtained, like you can see in the figure 1 here. Yes, and this figure shows the load curves for hot, cold, and mild days. As mild and hot days in Brazil are very similar, okay, especially in some states in Brazil. Only one curve was generated for these two commercial cases, where the use of, for example, air conditioning is present of these two types of days. In relation to residential curves, we have three different curves in the analysis: cold day, mild day, and hot day. Okay. For this analysis, it was also necessary to collect data of harmonic spectrum for the different loads, how we can see here in the table 2. Okay. And that may be present in Brazilian distribution system. Well, and this table presents the magnitude, the angle, certain of each equipment. Okay, this is maybe the most difficult part of the data to obtain. Yes, well, and the system used has loads. So according to the table 2, we can see. Here the quantity of loads. You have almost 600 loads of the system, and you divide it in some spectrum, harmonic spectrum, and the load shape. Okay. Well, you have a total of 7 kVA of photovoltaic system was inserted. And what else? With the system ready, and the study of losses to the harmonics was currently out in OpenDSS, using the software because it's very good to analyze these cases, and user interface with MATLAB. Okay, to calculate the power flow for each climate, okay, in each case, and here we can see the results. Here we have the loss to the harmonics of order 3 to 9, yes, and here we have to the harmonics of order 11 to 19. Okay. For each case, the flux was considered every hour, okay, performing the fundamental power flow, and then for each harmonic. Thus, the results you can see here. For each case 1 is cold day, case 2 it's a mild day, and case 3 it's a hot day. Okay. For more, these losses for all harmonics are greater for hot days, how we can see. In figure 4, it's clear to observe the influence of losses to the harmonics in the system. Yes, and you have heard, for example, this 20% being basically divided between the third, 50, 70, and 90 quarter harmonics, while the other harmonics cannot reach 1% of losses. Okay? How you can see here. Therefore, it's appear that there is a considerable influence of harmonic in the calculation of electrical losses in distribution networks. However, the difficulty in having information about these harmonics is the networks it's no. Okay. Well, that's all, and I want to thank the entire organization of this conference, especially Professor Manuel and his team, who has always given us support, and very sad to be not to be present at the conference, but we know that it will be a success. Thanks a lot. Bye bye.